Hello and welcome to Database Management Systems. I'm Chavita Christie, and in this video, I'm going to explain to you query equivalence rules. These rules allow us to convert one query into another type of query so that we can optimize that query and make it work with less cost to the system. So let's begin. This is the first rule, and it's a very simple rule. It says that conjunctive selection operations can be deconstructed into a sequence of individual selections, and the transformation is known as a cascade of sigma. Now, all the operations and rules that I'm going to explain to you here, they are all going to be in terms of relational algebra operations because we cannot write them in terms of SQL since SQL does not show procedure. So if you see the example given there, E is a relation and the conditions which are mentioned outside are sigma conditions. So you can see that there is a sigma operation which is showing theta 1 and theta 2 as two different conditions. And then you can see that theta 1 and theta 2 is written on the left side of equal to, which means theta 1 and theta 2 are two different conditions. And the operation AND, which is there in between, is known as a conjunctive selection. And whenever there's a conjunctive selection, you can convert this into sigma theta 1 and then put a bracket sigma theta 2. So you can separate out your conditions in this manner. Another type of rule says that selection operations are commutative. So if I have an operation where, if I have a select operation that I'm performing on a table named E, and first, if you see on the left-hand side of equal to, then first I'm applying theta 2 on E, and then I'm applying theta 1 on E. But on the right-hand side, you can see I'm applying theta 1 condition on E, and then I'm applying theta 2, and it doesn't matter because these select operations are commutative. The third type of rule says that only the final operations in a sequence of projection operations are needed. The others can be omitted, and this transformation can also be referred to as a cascade of pi. Remember that the pi operation extracts columns from a particular table. So the table name here is E. From that table, pi operation is extracting several columns. Now you can see on the left-hand side, I'm applying the pi operation multiple times. And every time I'm extracting a different column like L1, L2, and so on up to L4. But the only thing that matters is L4, the only thing that matters is L1, which is the final list of columns that I'm extracting. It doesn't matter what you extracted in between because the final result is only going to show L1. And that's why on the right-hand side, it's written that all these things together, they can be made equal to just pi L1 of E. The next condition says selections can be combined with Cartesian products and theta joins. So I'll explain to you here what a theta join is. So let's see part A of number 4, which says that if you have sigma theta, theta is the condition which you are using along with select, and there are two tables, E1 and E2. On both of them, you're performing a Cartesian product. Now, after performing a Cartesian product, what you have is this can be made equivalent to E1 natural, not natural join, but a theta join with E2. So what exactly is a theta join? Remember that a natural join is a join that performs a simple equal to operation between the columns of E1 and E2, which are common, which have a common name. But a theta join can do much more than just equal to. A theta join would be able to do greater than, less than, greater than equal to, or less than equal to, these types of conditions. So if you want to apply that, then you can use a natural join symbol along with a theta condition, which means you don't want to perform equal to, you want to perform something other than equal to. And that is what a theta join is. Now consider what you have in part B. In part B, once again, you have a select operation and this time too, you have a theta operation, but the theta condition is only theta 1. Inside, you already have a theta join with a theta condition theta 2, and you have E1 and E2 two tables. Now this can be transformed into what you can see on your right hand side, which says E1, and then we are combining the two theta conditions by putting AND operation in between. So it's theta 1 and theta 2, and then E2 relation. So this is our fourth rule. The fifth rule is that theta join operations are also commutative. So if you have a theta join operation like this, E1 theta join with E2, you can also perform E2 theta join with E1, and you would still be getting the same result. The sixth rule says that natural join operations are associative. Associativity deals with the placement of brackets. It just tells you which operation is performed first and which is performed next because of the priority given based on the braces that you put around those. So let us see on the left hand side, you have E1 and E2, two relations, and we are taking natural join between those two. And after doing this, we are taking a natural join of the result of E1, E2 with E3. But on the right hand side, we are first performing a natural join between E2 and E3. And then with the result of that, we are performing a natural join with E1. And that's why we can say that natural joins are associated. The seventh rule says that the selection operation distributes over the theta join operation under the following two conditions. So this is the distributive property of sigma with theta. The first condition says that it distributes when all the attributes in the selection condition, that is theta, involve only the attributes of one of the expressions, say E1 being joined. So all the attributes which are present in the theta condition, they are only involving the attributes present in one of the relations. And in this case, we can say that it is involving, say, E1's attributes. So when I'm writing sigma theta 0 and theta 0 contains only all the columns which are present in E1 but not the columns present in E2, then I do not need to perform sigma over the whole theta join performed on E1 and E2. I can perform sigma over the theta join performed only on over the relation E1 and then take a theta join. So because all the columns of theta 0 belong to only E1, I can apply the sigma to E1 alone and then take a theta join with E2. The next rule, which is the rule 7b, it says that it distributes when selection condition theta 1 involves only the attributes of E1 and theta 2 involves only the attributes of E2. So this time we have two conditions. On the left-hand side, you can see there is an operation sigma theta 1 and theta 2, which is applied on the theta join taken between E1 and E2. But the condition says that theta 1 contains all columns of only E1 and theta 2 contains only all columns of E2. So if you have this type of a condition, then you can convert it into sigma theta 1 of E1, which means first you are applying the sigma condition to E1, and then you are taking a theta join by applying this theta 2 condition to E2. Because we know that the columns of E1 are in theta 1 and all columns of E2 are in theta 2. So that is why we can perform it in this manner. So this is our seventh rule. Now let's see our eighth rule. The eighth rule says the projection operation distributes over the theta join operation under the following conditions. So the previous rule was about the distribution of sigma. This rule is about the distribution of pi. So in this case, let L1 and L2 be attributes of E1 and E2 respectively, which means L1 columns belong to E1 and L2 columns belong to E2. Now suppose, and of course E1 and E2 are both tables, suppose that the join condition theta involves only attributes in L1 union L2. That means when I'm writing a theta join, then in that theta condition, all the columns that are used are only the columns that are present in either L1 or L2 or both. So in that case, I can again distribute the pi operation in this manner. You can see there is a pi operation on the left hand side. There's a pi operation that says L1 union L2 on E1 theta join E2. This can be converted into pi L1 of E1. That means you extract all the columns that you need from E1 and you extract all the columns that you need from E2 and then take a theta join between the two. So this is part A of Rule 8. Let us see part B of Rule 8. In this, we have uh, a join that is of the type E1 theta join E2, and let L1 and L2 be sets of attributes from E1 and E2 respectively, just like before. But there's also another set of attributes, which is L3, which are attributes of E1 that are involved in the join condition theta, but they are not present in L1 union L2. And then there's another set of attributes L4 of E2 that are involved in the joint condition theta, but they are also not present in L1 union L2. So once again, that's quite a mouthful. So let me tell you that once again. So there are two tables, E1 and E2, and we want to perform a theta join between E1 and E2. Now the theta condition uses some columns from E1 and E2. And other than that, we are also performing a pi operation where we are extracting columns, a list of columns. Remember that L1 and L2 are not two columns, they are a list of columns. So we are extracting L1, which are some columns from E1, and we are extracting L2, which are some columns from table E2. And other than that, the theta operation is using some columns L3, which belong to E1, but they do not belong to L1 or L2, which means the union of L1 and L2. And we also have some columns L4, which belong to E2, but they do not belong to L1 union L2. So that is the type of thing we are trying to do here. And you can see on the left-hand side of this result, you can see that there is pi L1 union L2, which we are trying to extract. And in bracket, we are trying to perform a theta join between E1 and E2. Remember that the theta join is being performed using columns, a list of columns L3 and L4. So this would be equal to, what you can do here is keep pi as it is. So we are keeping pi L1 union L2 as it is outside the bracket. And inside the bracket, we are trying to extract the columns. So from E1, the columns that are necessary are columns L1 and L3. And from E2, the columns that are necessary are columns, list of columns L2 and L4. So we are getting those columns out first. And after doing that, we are performing a theta join. And after we finish doing the theta join, then we extract only L1 and L2 columns, which need to be displayed as a result. So I hope you understood this. If you did not, please read it once again. It's not that difficult. And that's it for this video. In my next video, I'm going to talk about couple more rules, and I'm going to tell you how to use these rules in order to transform one query into an optimized query. And we're going to see that in the next video. So I'll see you in that one. Thank you for watching.